Hey everyone, and welcome to another episode of Mrs. Ross Does Math. Today our lesson is on Math 8. This is for Lesson 18, and our topic is applying the Pythagorean Theorem. Alright, let's get this started. So, when we are applying the Pythagorean Theorem, this is a very practical way for us to practice how we can use math in real-world scenarios. Especially if you're going to be working in construction, engineering, mechanics, anything like that. The Pythagorean Theorem is going to become one of the tools and one of the formulas you will be commonly using. So, let's get some practice in using it. Once again, this is Lesson 18, our topic, applying the Pythagorean Theorem. Here we go. Our essential question for today is how can I apply the Pythagorean Theorem to solve problems in 2 and 3 dimensions. Now, for this today, all of your problems are going to be word problems. You only have 6 on your assignment, and I'm going to be doing 2 of them with you to kind of guide you through the process. So that will leave you with 4 problems left to do. If you have any questions at all, please leave me a comment, send me a message. I'm here to help any way I can. So to begin with, when we are looking at applying the Pythagorean Theorem, we have a couple of key steps that we can use to solve in our application of word problems. And the first thing that we can do to help us out is to draw a diagram to represent the situation. In your problems, you're going to have words like north, which would mean we draw a line going up. South, we draw a line going down. If it's a ramp is something that's on a diagonal. Think of it like you're trying to unload a big heavy dishwasher using a dolly. You're not going to just go down a set of steps, not the easiest way. What you're going to want to do is to be able to go down a ramp, which is a diagonal distance, to make it a little bit easier. So we always want to try and draw a diagram to represent the situation. The second piece that we're going to want is to label the diagram with the given measures. In your problems, you're going to be seeing measurements like 3 feet, 2 yards, 60 miles. So you're going to want to pay attention to those unit of measurements as well. Third, you're going to want to solve for the missing measure. This means ultimately when we get our answer, we're going to need to use that unit of measurement. We're going to need to label it. Okay, so that's it. We're going to be using the Pythagorean Theorem to solve these. So as always, please make sure that you have that listed. And that is a squared plus b squared equals c squared. And here we go. So our problem for today says a ramp has a horizontal distance of 10 feet and a vertical rise of 3 feet. Find the length of the ramp and round to the nearest tenth. Now, here we're talking about a ramp. A ramp, once again, is something that is diagonal. So for this, when we talk about a horizontal distance, that's going to leave us with the 10 feet, which is our horizontal distance, on the bottom, a vertical rise of 3 feet. So here we're going to go up 3 feet and then find the length of the ramp. The ramp once again is our diagonal and we don't know it, so our ramp is our x. Now ultimately we're going to be rounding to the nearest tenth, so we're really going to want to pay attention to our digits as we go through this problem. So here we go. So once again, we're going to be using the Pythagorean Theorem to solve this. So I have a squared plus b squared equals c squared. The ramp, that is always opposite of our right angle. So our ramp is x. So I'm going to plug x in the space for c. Now that's going to leave me with the legs, which are a and b. I'm going to put an a next to the 3 feet and a b next to the 10 feet. So I'm going to write 3 squared plus 10 squared. So I actually have an equation that says 3 squared plus 10 squared equals x squared. Now 3 squared is 3 times 3, so I'm going to put 9. plus 10 squared, which is 100, or 10 times 10. And once again, that's going to equal x squared. Now I'm going to add the 9 and the 100 together, which would give me 109. And that's going to leave me with x squared. Now, I'm going to need to square root both my x squared and the 109, because what we do to one side, we also do to the other, in order to get rid of my squared. When I do that, that's going to leave me with x. And when we get our answer, it's going to be something approximately 10.44. Now, because we're rounding to the nearest tenth, the first 4, the first digit behind our decimal, that's the tenths place. We are going to look to the number next to it to see if we are going to round up or if we're going to stay the same. Because this is a 4, we're going to go ahead and keep our underlined 4 exactly the same. Nothing is going to round up. So that means that our answer is going to be 10.4 equals x. Now, ultimately, we need to label our answer. Because this is a word problem, we need to make sure that not only do we have our units of measurement, but we also need to state this in words. So I'm going to state down here, the ramp is 10.4 feet long. And I'm going to circle it. Okay. So once again, we began by identifying the parts of our triangle. Whenever we talk about Pythagorean Theorem, we're using it with a triangle. So if you're having trouble differentiating between what's a leg, what's my rise, what's my horizontal, what's my vertical, what's my diagonal, always remember that it's going to be a triangle. If we talk about something that's horizontal, that's going to be a straight line across the bottom. Vertical, or a rise, is going to go up. And then that means our missing length is what we're trying to find. Now, that's it for our notes. Before you go ahead and start our worksheet, let's go ahead and review this once again. So, to begin with, when we're solving application problems, meaning we're taking a topic and we are applying it to a real-life situation, we want to draw a diagram to represent the situation. Then we want to label the diagram with the given measures. And lastly, we want to solve for the missing measure and label our answer. So, with that in mind, I'm going to go ahead and get started on your assignment. So here we go. So our assignment is Math 8, Lesson 18. Please make sure that you write your name, today's date, and the class period at the top of this paper. This is for Math 8, that is class period 1. My name, Mrs. Ross. So, taking a look at this, our instructions state to draw a diagram and solve the missing measure. Round to the nearest tenth. So we are going to have to do some rounding here, so we're really going to need to make sure that we pay attention to those numbers. Taking a look at number 1. It says, a car travels 60 miles due north. I'm going to underline that because that's a key piece of information. And north, when we travel north, I'm going to go ahead and put an upwards arrow. That's going to help me out here. Next, it travels, then it makes, I'm going to start that over. A car travels 60 miles due north, then it makes a turn due west. It travels 72 miles west. I'm going to underline 72 miles and west. And when we look at a general compass, we have north, south, east, and west. So I'm going to go ahead and put my arrow for my west going to the left. Now it's asking me how far is the car from its starting point. So let's draw that diagram. We first travel 60 miles north, so I'm going to draw a line going up, and I'm going to put 60 miles next to it. Then the car makes a turn going west. I have to have another line, and I'm going to write 72 miles. Now, ultimately, every time that we're working with Pythagorean Theorem, we will have a triangle. That means that now what I have is a diagonal. And my question is, how far is the car from its starting point? That is what I'm trying to find. So, putting this together, we have our theorem for Pythagorean, or our formula for Pythagorean Theorem. which is a squared plus b squared equals c squared. Because this question mark, or my missing distance, is across from the right angle, I'm going to use that as my c. So I'm going to put an x in the space of my c with a square next to it. And then I'm just going to write a and b. A next to the 72, b next to the 60. So I'm going to write 72 squared plus 60 squared equals x squared. Now 72 squared is 5,184, because again that's 72 times 72, not 72 times 2. So 5,184 plus 60 squared, which is 3,600, and that equals x squared. Next, I'm going to add the 5,184 and the 3,600 together, and that's going to leave me with 8,784, and that equals x squared. Once again, we want to get rid of that squared, so I'm going to square root both sides, and my x is going to be 93.72. Now, once again, we need to round this to the nearest tenth. So we're going to take a look at this 7. Are we going to round the 7, or is the 7 going to stay the same? This too determines if the 7 is going to change. Because this number is less than 5, it's going to stay the same. So our answer is going to be 93.7. We had miles, so we're going to need to include that. So 93.7 miles equals x. Now, once again, this is a word problem, so we need words in our answer. So we're going to write over on the side, the car is 93.7 miles from its starting point. And there we go. All right. Next, we're going to move on to number 2. So here we go. Michelle delivers books to school libraries. Her truck has a slide-out ramp for unloading the books. The top of the ramp is 3 feet above the ground, and the ramp itself is 5.2 feet long. What is the horizontal distance between the ramp? What is the horizontal distance the ramp reaches? So, once again, let's take a look at the information we have here. It says the top of the ramp is 3.2 feet above the ground. So if I'm on a truck, I'm going to state that this is my truck here. Boom. There's my truck. Okay. The ramp of my truck is going to start right here in this spot. And that's 3 feet from the ground. So this arrow right here, that's my 3 feet. Next, the ramp, the piece that comes off of the truck and angles down, is 5.2 feet. Next, it asks, what is the horizontal distance? Well, that's going to be the bottom. That's going to be the distance between the ground and where the ramp reaches. Now, because this figure is really small, I'm going to go ahead and draw a larger one. So once again, our truck ramp is 3 feet from the ground. The ramp itself is 5.2 feet, and it is our task to find the distance between the ramp on the ground from the truck and where the ramp ends. Now, the 5.2, that's on a diagonal. That is opposite of our right angle, so that's our hypotenuse. In our formula for Pythagorean Theorem, a squared plus b squared equals c squared, the 5.2, that's going to be our c. So I'm going to put a c next to it. Now the 3 can either be a or b. I'll leave it up to you. I'm going to put it in as a. So I'm going to put 3 squared right there. I'm going to put an a underneath it, and that means my question mark is my b. So I'm going to put plus b squared. And I'm just going to leave it as b this time, instead of changing it to x. Now, I'm going to go ahead and solve. 3 squared is 3 times 3, which is going to give me 9. My b squared is going to remain, and that's going to equal 5.2, which happens to be 27.04. 5.2 squared is 27.04. Now I'm going to have to subtract 9 from both sides, and when I do that, I'm left with b squared equals 18.04. Now I'm going to need to square root both sides, leaving me with simply b is equals to 4.24. We're going to have some more digits behind our number, but because we're rounding to the nearest tenth, the piece that we need to pay attention is to the 2 and the 4, because both of those digits are behind our decimal. Now once again, this 2 is the number that's going to look at changing. Because the 4 next to it is below 5, that 2 is going to stay the same. So that means that our answer for B is that it's 4.2, and in this case, feet. So B is equals to 4.2 feet. Now, once again, we need to put this in a sentence. So we're going to state the horizontal ramp, or the horizontal distance the ramp reaches is 4.2 feet. And there we go. So again, the horizontal distance the ramp reaches is 4.2 feet. Now, if you have any questions at all, please feel free, rewatch this video, look over the notes, the example that I gave, slow this down, send me leave me a comment, send me a message. I am here to help. Thank you so very much for watching. This has been Mrs. Ross Does Math.